I do have a YouTube channel, Math with Kim, that I've started to help students to do this. So I have other videos that explain prime factorization. So we're not going to go into that today, but I will be using that to simplify these roots, okay? So we're looking for pairs. When we're talking about a square root, we're looking for pairs of factors that we can take out of the root. When we're looking at cubed roots, we're looking for 3 of the same factor, so 3 of a kind, in order to take it out of the root, okay? So first I'm going to rewrite my square root. And next I'm going to break down my 36 into prime factorization. Now just as a quick, simple review, 36, a lot of us think of it as 6 times 6, right? And 6 is not prime, it breaks down into 2 times 3. And the other 6 also breaks down into 2 times 3. So our prime factorization of 36 would be 2 times 2 times 3 times 3, okay? And again, if you remultiply that, 2 times 2 times 3 times 3, you'll get back to your 36, okay? Now, y to the 4th would be written in broken down factor form of our base is y, and the exponent means we're multiplying it, in this case, times itself 4 times. So as you can see, this is our broken down prime factorization, and what I'm looking for, again, because of the fact that we have a square root, we're looking for pairs. So I have 2 2's, which means one of the factors of 2 will come out of the root, okay? I also have 2 3's, so a factor of 3 will come out. Now be careful, because when your factors are coming out, you need to multiply those factors as they come out, okay? No addition, that's a mistake that's commonly done. When factors are coming out, the definition of factor is multiplication, okay? Now, any more pairs? Yeah, we have more pairs. I have a pair of y's, 1 pair of y's, so I'll take 1 out, and I have a second pair of y's, so another y will come out, okay? So now, what is that when we put it back together? Because once we pull all the factors out, there's nothing left, so nothing is left under the root. And so therefore, we're just going to combine by multiplying the factors that we got out. So 2 times 3 is 6, times y is 6y squared. So that is our simplified answer for the square root of 36y to the 4th. Okay, now we're going to move on to b. Now b is the cubed root. Now with a cubed root, we're looking for groups of 3, okay? So again, what we're going to do is break this down to the prime factorization. And by doing that, our 24 is going to be 2 times 12. 12 is 2 times 6. 6 is 2 times 3. And there's no more factors left, so there's our prime factorization. So we'll put this back under its, be careful, cubed root. Please make sure to include your root. If you don't, your answer is incorrect. So this 24, we're going to break down into its primes, organized as 2 times 2 times 2 times 3. Now, we have x to the 3rd, so it breaks down into x times x times x. And then we have y to the 5th, okay? Y to the 5th, I'm going to organize as y times y times y times y times y. So there's 5 of them, okay? So now, what are we looking for groups of? This one was a square root, so we're looking for groups of 2. This is a cubed root, so we're looking for groups of 3, or 3 of a kind, okay? So we have 3 2's, so that means a factor of 2 escapes. We have 1 3. We'll come back to that one because we don't have enough, right? We need 3 3's. We don't have it. Do we have 3 x's? We do. So that means one factor of x will come out of that cubed root, okay? Let's look at our y's. Do we have a group of 3? We do. We have a 3 of a kind right here. So that means one of our y's comes out. Do we have another group of 3? No, we don't. So therefore, we have leftovers, right? So what do we do with leftovers? Well, in this case, we have a 3 and 2 of our y's. So what does that mean? Well, that means we're going to rewrite our root because we have not gotten rid of our root like we did in this case. We had no leftovers, so there was no need for a root. But in this case, we've got some that didn't escape. Remember to bring again, it's a cubed root. Don't leave that behind. Common mistake, okay? Our 3 is left and y to the second is left, okay? So this would be our simplified radical for our cubed root. All right? Okay, so now let's do one more, and in this time we're going to do a fraction. We're also going to include a negative because we haven't looked at a negative just yet, but it's done the same. So let's give ourselves some room. And example C, we're going to have a negative, and this time we're going to have a 4th root. In the numerator is 81 x to the 4th, y to the 8th, and in the denominator 16. Okay, so one of the ways that we can simplify a radical that's in a fraction is we can either simplify under the radical or we can break it into 2 radicals. And I'm going to do that right now because most of the time you're going to be able to simplify the numerator and the denominator separately, okay? So what we're going to do is we're going to retake our 4th root of our numerator, 81 x to the 4th, y to the 8th, and divide that by, and don't forget this is a negative, so I'm going to bring my negative down, okay? Don't leave your negative behind. And the denominator, I'm going to take the 4th root of 16, okay? Now that we've separated that, I'm going to get rid of the second half of this problem, and it'll give us a little bit more room and a little bit more space to concentrate. So now, let's do the prime factorization of 81, all right? This is a 4th root. It's negative, so I'm going to keep that negative. And now, under this root, I'm going to rewrite it. Again, 4th root, don't leave that behind. 81 is 9 times 9, and 9 is 3 times 3, and the other 9 is 3 times 3. So 81 prime factorization is 3 times 3 times 3 times 3. X to the 4th is, of course, x times x times x times x. And y to the 8th is, of course, 8 factors of our y multiplied by itself, right? Okay, now 16, do prime factorization here. This is 4 times 4. And each one of these 4s breaks down into 2 times 2. So the prime factorization of our denominator, which again, don't forget, 4th root, is 2 times 2 times 2 times 2. How convenient, right? There's 4 again. So the next lesson will go and show you the shortcut method of simplifying those, okay? Instead of breaking these down, I'm really doing this so you can understand and comprehend how you can do these, okay? So a 4th root means, again, we're looking for groups of 4. So you can see we have a group of 4 of 3s, we have a group of 4 of x's, we have 2 groups of 4 of y, and that's our numerator, right? So if we were to rewrite this, the 3 escapes, an x escapes, and 2 y's escape, right? So this still is a negative fraction. That hasn't gone anywhere. A 3 has come out of our fourth root. An x factor has come out. And 2 y's. So in other words, y squared. Okay? And in the denominator, well, we've got 4 factors of 2. And that's what we needed. So that's exactly what comes out. Okay? So our simplified root is negative 3x squared divided by 2. Okay? So this is simplifying some of the basic square, cubed, and fourth root examples.